Alright, so let's go ahead and begin here, because we're talking about segment addition postulate. It's not like we're doing anything amazing today. It's literally using that postulate to solve for segment lengths and other pieces, and solving for x. It's really not that big a deal. In fact, guys, we already did the majority of this lesson up front. And that is, if I look at my whole segment here, guys, what is my whole segment?
A, B, C.
No. AC is the whole segment. From one end to the other is the whole segment, Christina, right? A to C is the whole segment. So, if I take out my two parts, what are the parts of this whole segment? A, B, and B, C. So you guys already told me, if I take out those two parts, right, if I take out A, B, and I add it to B, C, what do I get? I get the same length. And that basically is the segment addition postulate. So if I take AB plus BC, it equals AC. It's this really fascinating and really mind-blowing concept, okay, that's a little bit of sarcasm there, that the sum of the parts equals the whole. That's the entire concept of today's lesson. The sum of the parts equals the whole. And just as a little bit of review, guys, what does the word sum tell us to do? Add. So if I add up all my parts, I get the whole thing. Now, I do want to point out one thing right now. I'm going a little fast, and I'm sorry for the years we're trying to get that. This little guy right here, that's what we call a geometric equation. Now, I want to take a little bit of time here, and I want you guys to think about this. When I ask you guys, give me a basic algebra 1 equation.
X minus 2 equals...
Okay, x minus 2 equals 4. Okay, that's an algebraic equation. X minus 2 equals 4. Which one of those is the variable? X, right? Okay, guys, here's the thing. When we have a geometric equation, like what's highlighted here, AB plus BC equals AC. Which of those is the variable?
AC.
Okay, they're all variables. And here's the thing, guys. You're so used to Algebra 1 where the variable is one letter, right, Amber? X, Y, Z, Q, P, who cares? It's some letter. In geometry, the name of a geometric part is our variable. So AB is not two different variables, that's one, because it represents one segment. So that could be a variable. BC might be our variable, or AC might be our variable. And what I want you guys to do first is before you dive right into these problems, start writing out the geometric equation. Because later on what's going to happen with that is if you write that out, then eventually what will start happening is it'll tell you, well, AB is 15, AC is 25, solve for BC. So what do you have to do? If you already have that set up, and you're given AB and you're given AC, what do you have to do? Just plug them in. And it becomes an algebra 1 problem. So always start with your geometric equation. That's really, really important with that. So, move on to the next one here. We're going to practice writing out a geometric equation. So we look at QT, or QS. How can I write QS using the segment addition postulate? Who wants to try that? Think about the parts. Okay, Brandon?
Are we just doing Q to S?
Q to S.
So I'm going to say Q plus, or QR plus QS equals...
Okay, so QR plus what?
RS.
RS.
Yeah.
Equals?
QRS?
No, just US. Okay. So when we name segments, we choose 2 points. Okay, so the whole segment would be QS. So QR plus RS equals QS. Who wants to try QT? How can we write QT and using the segment addition postulate? Okay? QR plus ST, does that equal QT? Okay. Amber?
Would there be QR plus RS plus ST?
There we go. Yeah, we're missing a piece in there. So QR plus RS plus ST equal the whole thing. Hey, Blaine, what about number 3? PR.
PQ plus QR equals PR.
PQ plus QR equals PR. Very good. And Callie, what about number 4? PS.
PQ plus QR plus RS equals PS.
Well done. Okay, guys, how hard is that, right? Sum of the parts equals the whole. Got this idea? Okay. Guys, a lot of geometry is mastering the concept before you master the implementation. So do we get it? The sum of the parts equals the whole. All right, let's do some exercises. Okay. Okay, look at number 5.